decades of experience of operating hardware in space for life support. We're in the upper 90% for our water reclamation and recycling, so that we don't have to ship heavy water up here. Today's coffee is tomorrow's coffee is the classic phrase. But yesterday I changed out a brine processor, which just allows us to eke out a couple more percentage points in terms of water reclamation. So in terms of discoveries, it's as much as about the new discoveries as it just figuring out how to make things last for such a long time in space. If you think about the Apollo program was about touching the moon, getting there, and coming back, and you only had to make hardware that lasted just that short mission. In fact, like less than 10 days. As we go forward with the Artemis program, it's about making hardware that lasts years and years and years of time in hostile environments. So that's really what we're doing, is we're putting time and humans for long periods of time on hardware to figure it out.
Yeah, excellent. The ultimate kind of reduce, reuse, recycle situation up there. Tracy, I've got chemistry questions for you. I saw an ISS post about electron precipitation, and it got me thinking, do we need to be worried about that kind of precipitation here on the Weather Channel?
Anytime we talk about electrons, I get kind of excited. But precipitation, I've never put those two words together. Electron precipitation. I don't think we need to be worried at all. We need to be worried if electrons stop spinning, because think about that. That's going to be a problem. But no, electrons are good. We need them up here to produce light. We need them up here to power our equipment and our scientific experiments. And the only precipitation I guess we got to worry about is what comes from the sun blasting our way. But we've got a whole team of super duper smart people that are tracking that stuff to give us fair warning. I don't know. We could just keep talking about electrons.
Yeah. Well, actually, speaking of... Do you have anything else to say about electrons? Happy to hear it, actually.
They're scared.
But speaking of, you mentioned, I'll put precipitation in quotes, coming from the sun, but the energy that we get from the sun, and I've been paying a lot of attention to that since we were talking about the aurora and the G5 geomagnetic storm. What do you do when there's a lot of energy directed at the ISS here? Is it just everyone inside? What is the protocol?
We have lots of policies and procedures. We work for the government, but it is well managed. We had these massive storms that were going on, but our first layer of protection is actually pretty much organic. We have the Van Allen belt, which takes a lot of that and directs it away from where we're at and protects us. It's one of the reasons we put the space station where we put it, is to be inside the Van Allen belt. Again, another concern as we go forward with Artemis is how we venture outside the Van Allen belt. Inside of that, we have something that we experience on a regular basis, which is the South Atlantic anomaly, and some of the radiation we experienced going through that was bigger than we would experience during the magnetic storms as we passed near the poles on the north and south side. Additionally, our orbit is limited to something a little bit less than 52 degrees inclination, so we were pretty well protected in this last storm. We had mitigations. Our teams know exactly where on space station are more protected or more insulated from radiation that we can go. And if we really have to, we have procedures to bunker down and surround ourselves with radiation blocking material.
Okay, interesting. Thank you.
One little add to that.
Yeah.
We're all kind of considered radiation workers. We're all kind of considered radiation workers. And I was fishing out my radiation dosimeter, which each of us have. And they give us some real-time readings. And aside from those particles that we get from Mr. Sun, we're always bathed in galactic cosmic rays, and that's actually where we get some of our higher equivalent doses, because those are coming in fast, they're high mass, and they pack a lot of energy. And as much as anything, that's what kind of limits our stay in space. So it's something we think about from a human standpoint, a medical endurance standpoint, quite a lot.
Are any of those, though, positive or beneficial? I'm thinking of the red light and blue light masks. You might have seen them on social media that are all the rage right now. And, certainly just the vitamin D we get out of sunlight here. Is there a benefit to some of these?
Well, I have told my children that the space radiation I get up here gives me superpowers. They don't buy that. But in general, that's what we're talking about is really ionizing radiation, very different from the color spectrum that might be all the rage down there. And we don't think there's really anything beneficial, but there is a line of research that looks at low doses, continual low doses of radiation exposure, which does have some interesting biological effects that may not all be bad. Right now, we treat it as something that's something fairly bad and something to be very, very careful of as we accumulate the absorbed radiation doses. So that's kind of where our headspace is.
Yeah, it makes sense. I'm gonna stay on this line of questioning, Mike, with you, because I know it's probably safe to say when someone asks, "Is there a doctor on board?" you probably raise your hand. But I wanted to ask, what kind of medical discoveries is the team working on specifically?
Well, in my mind, the biggest experience and knowledge base we get out of here is having people up here for long periods of time, and studying every system, because we know every system changes in zero gravity, and it shows us a couple of things. It shows us what the space-unique environment does to us, and that is changes to our bones and our muscles, our immune system, our cardiovascular system, how we're regulated, our brain shifts, immune system, everything changes. But it also shows how adaptable the human organism is in a way that we never really could have imagined. When you take away the dominant force of gravity, you find things that you wouldn't have found on the ground, and you think a couple of things that, number one, this seems to adapt us for zero gravity. Why that happens, not really sure. But number two, you find things that you didn't know the body was capable of doing, and that includes some of the ways that our blood system is regulated, some of the ways our brain changes up here, and everything from sodium storage in pools that we didn't even know existed in the human to counterintuitive changes in blood flow. We do get some vision changes. Whether those are a good thing or a bad thing is still up for grabs, but there's such global changes going on that it warrants a lot of study, and it informs us of the basic knowledge base of human physiology.
The body is so fascinating. It really is. Tracy, I wanted to switch gears again. I saw a really neat story about AstroBee Zero Robotics, which allowed students to write software to control a free-flying robot on the ISS. I thought, how cool was that? So how did that go, and how did it go working with the students?
Well, it's a lot of fun in a nutshell. But we have yet to start working directly with the students, because it's a competition. The zero-G part of it's a competition. Right now, what we've been involved with is getting the robots ready and kind of setting a baseline for how they will respond once they get this software that the students have written. And so we've got 3 AstroBees, the free-flying robots. I think their names are Bumble, Queen, and Honey. And so, everybody's got to have a name up here, and they each have different personalities, and we've been working to help the ground team set them up, get them in position so that they can receive commands. And then I've also got to do some fun sign language, basically, with the AstroBees in their gesture recognition software. And so I'm not sure exactly where all we're going to go with that, but I'm super pumped to be a part of it.
Yeah, that's really neat. Matt, as you know, and from Colorado, of course, you know firsthand how hard we are caring about our environment, how hard we're working to clean up our planet Earth. But I wanted to ask you about space junk. How often is space junk a threat to your work up there? And do you see it flying by?
Do we see other stuff in space? Funny you asked. Just the other night, I was in the cupola after work, and I was playing around with some cameras, and it was incredible to see other satellites out there. Over the past couple of years, we've seen this, probably exponential growth in number of satellites being launched into space. And it's really cool if this is the Earth in front of us, and we're here, and we're in the dark. The sun is on the other side of the Earth. And you can see the satellites that are up here, kind of like our organic satellite, the moon, reflecting light from the sun off the satellite into our eyes and into the cameras. And the other night, probably on a single, just maybe 5 to 10 minutes before sunrise, there's beautiful orange and green glow, and you could see the light reflecting from the sun off the satellites into our eyeballs, and it looked like they were swirling around. At least 100 satellites you could see with the naked eye. It was incredible. Was able to make a couple time lapse of the event. With regards to space debris and a threat, we have lots of people, international effort tracking space debris, and occasionally we'll get warnings about it might be an issue, and we have, of course, procedures to handle it. We can maneuver the space station as required with hours and hours of notice. We're able to do it. So lots of good efforts to protect us, and lots of cool stuff in low Earth orbit right now.
Very interesting. I really appreciate this time with y'all. This is really exciting. Matt Dominic and Mike Baird and Tracy Dyson, thank you so much for joining me from the ISS. This is literally an out-of-this-world conversation, and I can't wait to share it with everyone on the Weather Channel.
Awesome.
Really a pleasure to talk to you, Jen.
Yeah, thanks a lot, Jen. This has been a lot of fun for us, too.
Yeah, thanks a lot.
Station is Houston ACR. That concludes the event.
Thank you to all the participants. Station, we are now resuming operational audio communications.